You think you know what a force is, don't you? It's just a simple push or a pull. But what if I told you that in every quiet, still moment, there's actually a hidden battle raging all around us? Or that the simple act of walking is only possible because of a force we usually think of as the bad guy? Well, let's pull back the curtain and uncover the invisible world of force that's secretly shaping everything.
Okay, let's all go back to science class for a second. We all learned this on day one, right? A force is a push or a pull. It's the first thing every textbook says, and it's true. It's simple, it makes sense, and it's the perfect starting point for where we're about to go. But is that really the whole story? Not even close. That simple definition is like the cover of a book that's hiding an incredible, complex, and powerful world inside. It turns out that even in the most peaceful-looking scenes, there are epic struggles taking place. So let's start peeling back some layers.
Let's start with something you've seen a million times. A book on a table. I mean, it looks like the very definition of doing nothing, right? The complete absence of action. But in the world of physics, oh, you'd be wrong. This simple, boring-looking book is actually our first clue to a much deeper reality.
You see, that stillness isn't passive at all. It's actually the dead center of a perfectly balanced cosmic tug-of-war. What looks like simple rest is really an incredible dynamic balancing act between powerful, unseen forces. So here are the two combatants in this secret war. On one side, you've got the entire planet Earth using gravity to constantly pull that book downward. But at the exact same moment, the table is fighting back. It's pushing upward with an equal and opposite force. Physicists call this the normal force. The table is literally holding its ground, refusing to let the book fall right through it. And this right here is a perfect example of what we call balanced forces. The downward pull of gravity and the upward push from the table are perfectly matched. They're equal in strength, but they're pulling in opposite directions. So what happens? They cancel each other out. And this is so important. It's not a state of no force. It's a state of perfect balance. So when you add up that epic struggle, gravity pulling down, the table pushing up, what do you get? A big, fat zero. The total combined force acting on that book is zero. And that's what stillness really means in physics. It's not that nothing is happening, it's that everything happening is perfectly balanced. This brings us to a super important idea: net force. Think of it like the final score. You add up all the pushes and all the pulls on an object, and the result? The net force tells you exactly what's going to happen next. If the net force is zero, like with our book, nothing changes. But if it's anything other than zero, look out. That object has to start moving. Okay, so we've cracked the secret of stillness. Now let's move on to another force that gets a really bad rap. We're going to talk about a force that's often painted as the villain of the story, but is actually one of its greatest unsung heroes: friction. Come on, be honest. When you hear the word friction, you probably think of something negative, right? It's that annoying resistance that slows things down. It's what makes machine parts wear out and break. It's the drag you have to fight against just to push a heavy box across the floor. But that's only one side of the coin. Because without friction, our world would be completely impossible. You couldn't walk, your feet would just slide out from under you on any surface. The brakes in your car? Totally useless since they rely completely on friction to work. You couldn't even hold on to your phone. It would slip right out of your hand. Friction isn't just resistance, it's the grip that lets us control our world. Now, friction is a perfect example of what's known as a contact force. And, well, the name says it all. These forces only happen when objects are physically touching. But not all forces play by those rules. So what about the forces that can act across empty space? All right, this is where things get a little weird, in the best way possible. We're moving on from the forces we can feel to an entire invisible universe of forces that work without ever touching anything. Welcome to the world of action at a distance. These are the non-contact forces. They're the silent, invisible architects of our universe. They don't need to make contact to have a massive effect, and they shape everything from the tiniest particles to the orbits of entire galaxies. So let's meet the three titans of this invisible world. First up, the big one, gravity. That's the silent, relentless pull that every single object with mass exerts on every other object. It's what keeps you on the ground and planets in their cosmic dance. Then we have magnetism, with its mysterious ability to both attract and repel. And finally, there's the electrostatic force, which is the engine behind basically all of chemistry, acting between all the little charged particles that make up, well, everything. These three forces literally weave the fabric of our reality.
Wow,
Okay, so we've journeyed from a simple book on a table all the way to the forces that govern the cosmos. So let's tie it all together. Let's build ourselves a new lens for seeing this invisible world of physics that is all around us all the time.
So, looking through our new lens, what did we discover? First, that stillness is never actually still. It's a perfect active balance of powerful forces. Second, that friction, the force we love to blame for our problems, is actually what gives us control and lets us move. And third, that the most powerful forces shaping our entire universe are the ones we can't even see.
You know, we started with a simple push or a pull, and we ended up looking at the invisible architecture of all of reality. The world around you is held together by this beautiful, intricate dance of hidden forces. So I'll leave you with a question. Now that you can see it, which of these forces are you going to notice most in your world today?